Okay, so what you have right here is a rectangle, okay? It's asking you to write two polynomials that represent the perimeter and area of this rectangle shown at, well, below in this case. What you need to think about is, we're talking about a rectangle and we're dealing with perimeter and area. Do you know the formula for the perimeter of the rectangle? Yes, what is it?
2 length plus 2 width.
Okay, so just like any other shape or object, if they're asking you to find the perimeter, let's start defining that first. Defining the perimeter, like you said, is 2 length plus 2 width, right? What about area? How do you find the area of a rectangle? What is it? Length times width. Okay, so the area is length times width. Why do you think I have to define these two first? What is the problem asking you to write? Perimeter and area. So at least I need to have some sort of structure to build, right? To build upon. If I don't have anything to start with, so how am I going to put the area of perimeter of this rectangle? Anyway, let's identify what we already have. Please understand something here, that we are no longer in the realm of, oh yeah, I give you the length of 5 and the width of 2. Find the area. You multiply. Easy. 5 times 2. 10. So the area of this rectangle is 10. Not that case anymore. Okay? We now have just a regular expression. Okay? I can express anything in terms of expression. Could be just made up just variables. And it doesn't matter. Whatever's given to you, you use what you have and try to put it in and build the structure that you have right here. So the structure tells you to, for example, the area is length times width. Do we have length already here? Mm-hmm. Even if it's not a number. But do we have it? Yes, we do, right? So what is the length? Okay, so we just say, okay, the length is this particular expression right there. 4x squared plus 2x minus 1. It's long, but it is the length, isn't it? Where's the width then?
2x.
Okay, so I'm just going to go ahead and identify that as well. That is my width. I have the length, I have the width. Can anyone here help me write our first polynomial for the area? How do you write the area of this rectangle? What do you say? What's the area again? Length times width, you said. Okay, so I know it's length times width. I have this blueprint right here. Length times width. You want the length?
Yeah.
So what do you write?
4x.
Okay, so we're going to start with that. 4x squared.
Plus 2x minus 1.
Okay, so is this your length?
Yes.
Okay, now what do we do with the length again?
Multiply.
Multiply, so multiply by the width, which is 2x squared minus x plus 3. And there you have it. Area is length times width. A basic structure, right? And you say, wait, can we do something more about this? Yes, we can, but wait until next week. For now, I just want you to set it up. That's it. Length times width. Questions at all? Okay, move on to the perimeter then. How do we set up our perimeter structure for this rectangle?
4x squared. Wait. 2x. No, it's like squared.
So how do we set the perimeter? Go back to the structure. What is it saying?
2L.
What does it mean to say 2L?
2 times 25.
Okay, 2 times the length. So how do you write that?
2 times 4.
2,
Parentheses.
parentheses.
4x
4x squared.
plus 2x
Okay, so that's 2L. Now what?
plus
Plus. Okay, plus
2
2.
parentheses
2x squared minus x plus 3.
Okay, any questions so far on that? That's pretty straightforward, isn't it? 2 times L plus 2 times width. And then we realize something too, that, hey, wait a minute, this looks very familiar. We should probably do something to this. Yes, distribute. Okay, so let's do that. Let's say we can actually distribute. I'm just going to draw my rainbow here just to make the connection. And let's distribute. What is 2 times 4x squared? 8x squared, okay. What is 2 times 2x?
4
4 what?
4.
4x, so plus 4x. Next, what is 2 times negative 1? Negative 2. Okay, then move on to this side. What is positive 2 times 2x squared?
4.
So positive 4x squared. Next, what is 2 times negative x?
2x.
Negative 2x. And what is 2 times 3? 6. Well, positive 6, right?
Yeah.
Okay, you see that right there? Any questions yet? Okay, so it's a mess. Still, even though it's a mess, we can call this still a very good looking mess. We'll clean it up, don't worry, we'll come back to it. But for now, at least we did some work on it. And until we learn the right tools to clean up some more, well, we're just going to have to leave this for now, okay? So any questions so far on what we just did to this problem? I hope it's easy now. Okay. So right here, if you notice, we have a lot of terms. A lot of terms. But some alike, which we will deal with later. But we have 1, 2, 3, 4, 5, 6 of them, which can be simplified later on. But yesterday we learned about a monomial. Mono, we talk about one term, right? Here, are we in the realm of mono anymore? Or we call this a lot of terms? And so when we say a lot of terms, we don't use mono, we use the term poly, right? So now, that's what we're trying to learn today, the term polynomial. Okay, let's write that first word down. And like we just discovered, poly means many, right? Many. And the word meal means terms. Monomial, nomial. Oh, I spelled wrong. Polynomial. There it is. Okay, so many terms. That's what we're talking about. And when we say many terms, it means 2 or more. So we want to be very specific too. Mono means 1. We learned that from yesterday. Okay, so that's 1. What represents 2? I just poly means many, but is there a word that represents 2? Huh?
By.
Die? Bi. Like bicycle? Alright? Bi means 2. 2 wheels. Bicycle means 2 wheels. So in this case, we know we're going to use that word bi. So we use the word, the prefix bi and the word nomial to form binomial. So 2 terms. What about 3 terms? Tri. Very good. So we use the term tri to represent anything that's 3 terms. Okay? And 4 terms, you can probably argue, say, can we use quadnomial? Well, it sounds weird when we say quadnomial. So instead of saying that, we say it's a polynomial of 4 terms. Anything beyond 3 terms, that's how we classify it. Polynomial of 5 terms, polynomial of 6 terms, polynomial of 7 terms, 8 terms, and so on. And so that's how we classify anything beyond 3 terms. So you can see that it's monomial, binomial, trinomial, but beyond that it's polynomial of 4 terms, polynomial of 5 terms. Questions so far? So let me show you something here. Tell me what this is. How many terms do you see here? 2. So we call this a? It's a binomial. That's easy. Okay. So binomial. What about this next one? How many terms do you see here?
4.
Think carefully.
Polynomial of 4.
Okay, so a lot of you would say it's 4 terms, so we call this a polynomial of 4 terms. Okay, but look carefully. Sometimes, like I said, looks can be deceiving for a good reason. Because notice this is not completely simplified. We've got to clean it up completely first before we classify the name to it. So if you look carefully here, is there anything that looks like terms to you?
Yeah.
The X? Well, okay, please understand something here. When I say like terms, I'm talking like identical variable and powers. Everything has to be identical, exactly the exact replica. So in this case, see this x squared and x, are these like terms?
No.
No, this is called x squared terms. This is called the x term. Even when you say it, they don't sound the same. X squared, x, not the same. But when you say 7x, 6x, all of a sudden you say, oh, they all end in x's, so therefore they are like terms. So when you see something that are like terms, you circle the terms and say, I will what to the like terms? What do you do? Combine. Do not say add. It's a misleading word too. Just say combine, because sometimes combining could have a negative and positive and you end up subtracting. Combining with 2 same signs, you end up adding. So just say combine as a general word instead of adding or subtracting. Combine means whatever I have, I put them together, whether they are negative or positive. In this case, I have positive 7x and I have positive 6x. They are like terms, right? So how many x's do we have total?
13x.
13x. People still argue about this. Like, wait, Mr. Nguyen, shouldn't we also do something with the x's? So like x plus x is x squared? But no. Didn't we learn something about x plus x is 2x and not x is x times x at x squared, right? Since we're combining, we are not multiplying, dividing. We are either adding, subtracting. So please get away from that. I have 7 x's and I have 6 more x's. I have a total of 13 x's. Give yourself a little example too. Like I have 5 books and someone else give me another 6 books. That's a total of 11 books. You would never say, I have a total of 11 books squared. Okay, that doesn't make sense, right? So be careful. Just give a little example. So now, because these are like terms, it's a total of 13. So when I write it, it's 2x squared plus 13x plus 5. So now, all of a sudden, instead of a 4 term, it is a trinomial. See it? So something that you need to remember on top of your head, say, did I clean that up yet before I say what it is? Because if it's not cleaned up or simplified, don't even classify its name. Okay, so now this is called a trinomial. Questions on that? On the classification? Pretty easy, right?
Yeah.
Okay, so now we understand how to classify the terms of the polynomial. We need to actually dig deeper and understand about the degree of the polynomial as well. So you're saying, what is a degree? Well, degree is nothing more than just it's the sum of the powers from the variables. Okay? Degree is the sum of the powers from the variable. So we have 2 things to look at. First of all, let me just give you a very simple monomial term. Watch this. I have 3x to the second y. Just say that. Okay? And this is how we classify degree. Degree, we look at the power. In this case, it's the power of the variables only. So I don't care about the 3. 3 is not a variable. I just look at the x. What's the power here?
2.
What's the power here?
1.
This is sometimes people would just skip over because they don't see anything. They assume it's a 0. But remember, if this is a 0, it won't even be here already, right? It'll be just 1. But so if you don't see the power, it means it's a 1. So the sum of the powers is 3. So therefore, my degree right here for this particular monomial is a third degree. That's it. That's how you classify the power. So here we go. Let's try another one. What is the degree here?
5.
5. Thank you. Notice how Brandon says 7, and then Jamie corrected and says 5. Remember, the definition is the sum of the powers from the variables, not the numbers, right? Because the number can be expanded and turn it into another number, right? Negative 5 squared. Oh, by the way, what is negative 5 squared?
Negative 25.
Wait, 25.
25,
right?
Negative 25. Reasons? If I have negative 5, the whole thing squared. That's negative 5 times negative 5, which is positive 25. But notice that this is written without the parentheses. Therefore, you have to take 5 squared first, then apply the negative last to make it negative 25. So something that you need to remember as well, as far as a negative number being squared. If it's the whole thing squared, yes, it will be turned into a positive. But without the parentheses, it will stay as a negative, even if you square it. Okay? So that's how we classify it. And on the other side of this, where we say it's a polynomial, how do we classify the degree? Well, let's take a look at this one. Imagine I have the following: 6x squared y to the third minus 2x to the 7y plus 5x to the 6. All right? So I have the following. What is this called again? Specifically? It's a trinomial, 3 terms. Cannot combine like terms, so of course I have to leave it as is. So how do we classify the degree of this trinomial, or also known as a polynomial, right? Many terms. It's easy. All you have to do is classify the degree of each monomial inside this. So what is the degree here? 5. What is the degree here? 8. Because this is a first degree, right? So 7 plus 1 is 8. What's the degree here? 6. here's the last step you do. You pick the highest degree, and that will determine your overall degree of this polynomial. In this case, it's an 8th degree polynomial. That's all you do. So for a polynomial, you choose the highest degree. For a monomial, you just add the sum of the powers of the variables. That's it. But for a poly, you just choose the highest degree of the polynomial, the powers that you have. Questions at all on how to classify the degree of a polynomial? Is that straightforward enough? Okay. All right. So last thing on the list here is to teach you how to sort your polynomial. Sorting by power specifically, and we have 2 types of sorts. By the way, if I ask you to ever sort numbers, how many ways can we what kind? How do we sort our numbers? Least to greatest, or greatest to least? Do we have like a specific term to describe from least to greatest? In the order, what kind of order is that? Huh? Say it again. Descending. So what's the other sort then? If it's not descending, it has to be ascending. So that's the kind of 2 type of sorts I want to talk about today. Ascending sorts and descending sorts. Okay, so let's take a look. So for sorting, we have 2 types. Ascending versus descending. And we know ascending means it goes up, right? Descending means it goes down. So up means from small to big. And descending means from big to small. So please understand the difference between the 2. Ascending, small to big. Descending, big to small. Okay? And we are sorting, when we say sorting, we are sorting by the degree, the power in this case. Okay? So sorting by power. Okay? So for instance, imagine I have the following polynomial. So what I have up here is 4 terms. 3x squared y plus 6 minus 5x to the 3rd y squared plus 7x to the 5th y to the 7th. Notice I read it fast, but technically speaking, I should have said 3 times x squared times y plus 6 minus 5 times x to the 3rd times y squared plus, okay, you know there's a multiplication in between, right? Okay. When I ask you to sort, for instance, I will give you a direction to sort because you would know whether it's ascending or descending, right? So I'll give you this. I want you to sort this in descending order. And when I say that, I usually would specify, remember we have multiple variables here. They have different powers. So when I ask you to sort, I will usually describe to you what kind of variable I want you to sort it by. So I'll say I want you to do a descending sort using x, for instance. So that means all that you need to focus on is the variable x and the power above it. And I just have to be in descending order, meaning from the biggest power to the smallest power. So let's take a look for x. This x has a power of 2, so it's the 2nd power. This x has a power of 3. This x has a power of 5. But then you look at here and you say, wait, this is 6. There's no variable in this. So then, if it has no variable, then what does it mean? What does it mean in terms of the power then? It has 0. Very good. 0 power. So that means even if it's not there, you have to logically think, if it's not there, meaning the power is nothing, right? And we learned that power nothing, meaning a 0. So technically speaking, there is an x to the 0 power right there. Isn't x to the 0 1? 1 times 6 is still 6. So even though it's not written, you should know that when a variable doesn't exist for that term, it is the lowest power. Lowest possible. So now we know where the lowest is, where the high is. Let's sort them from descending in descending order. Which one is the first to look at?
6.
Huh?
6x.
x5, right? The highest, right? So when we circle, don't forget, when we circle the sign in front as well. It's a positive, that's the starting, so we're gonna write 7x to the 5th, y to the 7th. We're done. Next one, what should be less than 5? X3. Once again, when I circle, I don't just circle the 5, I circle the negative in front of that as well. So when I put it here, it's going to be negative 5, x to the third, y squared. Done. Next. Okay, this one, right? 3x to the second, so I'm going to go ahead and write that. 3x to the second y. Done. Last but not least, plus 6x, and here I don't need to write x to 0. It's just a filler. I know it's there, but you know, it's written like that. And that's how we sort our cell in descending order. 5, 3, 2, none. See it? And if I say, how about ascending order? And all you have to do is just go backwards. 6, 3x squared y, negative 5x third y squared, positive 7x fifth y 7 in ascending order. Okay, so once you have one sort, you just have to do the reverse if you want to, or if being asked. Any questions so far on how to sort this stuff? Is that straightforward enough? Sorting in terms of degree, power, and I will classify which term to sort by. Okay? All right, let's go back to the previous problem now, and hopefully you have a better idea on what it is all about. Take a look at this. Is this ready to be classified by the term? Okay, so that means we can still have something to combine, right? Do we spot any like terms here? Ah.
X squared.
Okay, first let's identify x squared. So, okay, a good rule of thumb, use your shapes. Oh, if I see all the square term, I'm going to circle them all. The square terms, the square term. Notice when I circle the sign in front as well. What else is like terms? The x term. So I'm going to use a box in this case. Here's the box. Here's the box. What else? Any like terms left? Just the numbers, right? The constants. So I'm going to use a triangle and triangle. There it is. So now we have a very clear idea on what we need to put together. 8x squared plus 4x squared. What is that? 12x squared. So 12x squared. Next. 4x minus 2x. Okay, plus 2x. Next. Negative 2 plus 6 plus 4. And all of a sudden, we started with 6 terms, narrowed down to just 3 terms, and we call this it's a trinomial. Very good, we're done. This is the best we can do, and so we just leave it like that.
Can't solve it?
No, unless we know what x is, which we don't. We don't care at this point. We're just simplifying, right? We're not trying to solve, we're just simplifying. Okay, any questions so far on that one?
No.
Okay, good. Let's get a free quiz.
No.